In this short video, I want to talk about distributed systems. I've written an article about it, and the link to that article is posted at the bottom of this video, so you can go through it. In this video, I'll just walk you through that article, and I'll explain the key things that are part of the article. Okay. So, what are distributed systems? They are a group of independent computers which connect with each other to get a job done. Straightforward, right? They may connect to offer some service, share data, or simply store data. You can imagine like you have a set of three computers which are connected to each other. Okay, and each of them can offer some service. They can talk to each other, they can exchange data, they can store data, and things like that. Now, these computers do not physically share memory or processor. Okay, what this means? It means that each computer is performing a separate task. It's not like they are sharing, one computer is making use of another computer's processor or memory. So each computer is self sufficient basically. They can perform a computation. So one can do a sum, like one can perform an addition, another can perform subtraction, another can perform sorting, but they are utilizing their own resources basically. Although they can talk to each other, and one computer can ask another one to do certain task. Okay, so how do they communicate with each other? That's the next point. So they communicate with each other using messages. Okay, in a distributed system, the sender and receiver must be explicitly encoded in the message. Since you have since you have computers which are participating, in this distributed system, so whenever you are passing a message, I mean, whenever a computer is passing a message to another computer, the message needs to clearly tell that this is the sender and this is the receiver. Okay, that is important. And actually, whenever you have this modular architecture where you have different modules, then messages are a great way for the modules to talk to each other. Okay, messages should follow some protocol for consistency. I mean, it's pretty obvious, right? So it'll be good like if all the messages follow some certain rules. They follow certain format. Like, say we have a header. I mean, an IP header format. So likewise, you can have certain rules which each of the message can follow. Basically, it's pretty straightforward. Let's take an example. Say we have two computers A and B that can exchange messages. Computer A can ask B to compute sum of two numbers and send back the result. Likewise, we can ask A to sort a list of numbers. So each of them are doing a different task, but they can, if computer A wants to calculate sum of two numbers, it can ask B to do that. Okay. Likewise, so each of the computers are kind of knowing what the other can do. Okay, they have the interface knowledge. Okay, and they can ask the other systems to perform that job. Both A and B can take different roles depending on their hardware and software capabilities. Now, how can you? It's another concept is that given a set of computers, how can you organize them? So you may have heard about client server architecture or peer-to-peer architecture, right? So in client server, you have a client, or you can have multiple clients, and you have a server to which each of the client is sending requests to. Say for instance, you have google.com, which is, for instance, it's one server, and we are multiple clients who are trying to access google.com. So this is a typical client server architecture. Okay, mind you, it's not just limited to internet. Even on your machine, this kind of architecture is there. So for instance, if you write a program which needs user input, right, then that input will come from the keyboard, or from some file or some database. Now that module becomes the server and my program becomes the client. So it's not just web where this client server architecture applies. It can be beyond that. Okay, now there are some problems with this kind of architecture which can be handled, but they are there. Like if one of the if the server goes down, then the the application stops. The client will be sending requests but no response, right? Similarly, if the client size increases, then also performance will go down. So you have certain challenges with client server architecture, but the thing is that this model is good for service oriented architecture. Okay. Now, coming to the second one, the peer-to-peer model, when it makes sense. Now we are talking about distributed systems. In distributed systems, you have a set of computers which want to talk to each other. In that scenario, peer-to-peer model makes more sense, right? So if you see here, this functions more as a distributed system where workload is distributed among the computers. Okay, all computers participate in computation and they send and receive data. So you may be getting an idea that in client server it's mainly the server which is doing the computation, right? But here in peer to peer you have a set of computers which are dividing the work among themselves. Or you can have another system, a smart system which can divide the work among these set of computers. Okay, so if the system needs to store large amounts of data, then it can distribute the same among computers which are participating in this setup. So peer-to-peer more closely resembles the distributed system architecture. So to summarize, basically I'll again go back to the first point. What is a distributed system? So it is a group of independent computers which connect with each other to get a job done. Okay, I hope this gives you a sense of what are distributed systems. If you have any questions or you have any suggestions, something which you think I may have not conveyed rightly, then please drop a comment and I'll try to correct that. Okay, thanks.